there are different types of strength tests to be performed. However, the compression tests are the most common ones, and you can also calculate the tensile test, shear stress or transfer test. But in most of the cases, this compression test is very important parameter. So what you do, you take a specimen of cylindrical shape which is having a desired required size, and its strength which is to be found out is placed between the lugs, and the pressure is applied slowly by the hand wheel until the specimen breaks. So this is basically a very small, very simple type of equipment, and you see there are two lugs. So this is the fixed lug and this is the movable lug, and its movement is controlled with the help of this hand wheel. So you rotate this hand wheel and it will try to push this lug in this direction, and between the gap given between these two lugs, you place your sand sample of this particular cylindrical shape and fixed size, and so basically you apply the pressure from here, and the opposition in the pressure, you can say that this pressure is sensed up here with the help of a manometer, and if you know the area of your sample, you can easily calculate the compressive stress. So the reading of the pressure manometer indicates the compressive strength of the specimen. So if you have the pressure and if you know the area which is already fixed, so this strength can easily be calculated. So this is the diagram, and these are the two lugs. This one is the movable lug, and this is the this fixed lug, and you control the movement of this movable lug with the help of this hand wheel, and so the compressive strength can easily be calculated by measuring the deflection in the pressure manometer. So after this, the important property is refractoriness, and many times it is also known as the sintering point test. So sintering point, you all know that what is sintering. We have already discussed in the powder metallurgy that in the sintering all the particles are fused together and they are bonded together. So you measure that point where the sand particles get bonded or fused together. What you do, you take your loosely filled sand sample in a porcelain boat shape crucible. So there is a crucible which is in the form of a boat, and it is made up of porcelain material, and then you place it in the heated zone of a electric furnace. And when the temperature has reached about 1000 degrees centigrade, so you keep that temperature maintained up for at least for 2 to 3 minutes, and after that take out the board from the furnace and observe the surface of that sample to find out that whether the sintering has started or it has taken place or not. So that sintering can be determined with the help of a microscope. So you place your sample below the microscope, and then you try to see that whether the particle has fused together, or whether the sample has some cracking has formed. So if it is not sintered, then replace this boat again, place this boat in the furnace and try to increase the temperature in the increments of 50 degrees centigrade, and till up to that point, till the sintering occurs. So again you do the procedure, follow the procedure, and after 3, 4, 5 times following the same procedure, you will have an idea that you will reach the sintering point or the sintering temperature. So that can easily be visualized with the help of a magnifier or a microscope. So this is the refractoriness test or sintering point test. Then the last test is the measurement of mold hardness. So this is a very easy type of testing method, and it is performed with the help of a mold hardness tester. So this is a mold hardness tester, which is just in it is very similar to a dial indicator, and it is also has the same mechanism, and there is one at one end, there is a spring loaded steel ball, and which is hemispherical in shape, and so this spring loaded ball is pressed onto the compacted sand mold. So what you do, you prepare the sand mold. This is the cope part and this is the drag part, and then after preparing and before performing the casting process, you measure the hardness of this prepared sand mold. So what you do, you take this spring loaded ball and you press it at the surface up to this particular level. So you see somewhat this ball is bulging out from this particular level. So this is the ring or the flat surface. So this ball is somewhat bulging out from the surface, and then you try to press it by holding this device from this particular location, which is the plastic sleeve. So you try to press it onto the surface of this mold, and so between this movement from here to here, just a few micron of the movement of this steel ball, you will apply somewhat 980 grams of this load with the help of a spring loaded mechanism. And this depth of penetration, the the hardness is calculated with the depth of penetration inside any material. So this depth of penetration is directly measured on the scale. So this is a graduated scale, you see, and it ranges from 0 to 100. That scale is also known as the B scale. And suppose so you perform the testing at 4 and 5 locations, suppose in the middle and then at the corner, 4 corners. So you will take 5 reading, at least 5 reading, and try to measure the hardness. So if you get suppose 100 reading, so that 100 reading is virtually no penetration and the mold is very hard, and then relatively you can measure the hardness of this mold. And in most of the cases for this you can say green sand mold, you will have the hardness ranges between 60 to 80, and you can measure the hardness with the help of this simple instrument. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.